Hi everyone. Okay, today's topic, we've been dealing with radicals and how to simplify them. We are going to look at rational exponents, which are just fraction exponents, and then we're going to look at how they are related to radicals. The first thing I want to do is just kind of give you a demonstration. If I take the cube root of x squared times the cube root of x squared times the cube root of x squared. Just a sample problem. And if we were to simplify that, one thing we notice, it's the same three terms. So rather than, I might write it with this exponent, cube root of x cubed, x squared to the third power. So when we have this, the cube and the cube root cancel out, so this is just equal to x squared. And this is kind of the simplifying we've been working on previously. The thing I want to do is kind of relate this to how we can maybe think of it as a, what would the exponent be if we weren't using radical notation. So let me just say that this cube root of x squared is equal to x to the power of a. I'm just going to make x to a power, and a is the unknown power that I'm dealing with right now. So each one of these, that's x to the a times x to the a times x to the a. Well, when you're multiplying and you have the same base, you add a, and that is 3a. Now also notice that this times this times this was equal to x squared. So let's just set this, let's bring that down here. Set that equal to x squared. And I got the same base here. So essentially, my exponents, with that same base, the exponents would be equal. And if I just solve for this, then a is 2/3. So x to the a times x to the a, this is x to the power of 2/3. And I'm just checking this real quick. 2/3 plus 2/3 is 4/3. 4/3 plus 2/3 is 6/3. And 6 divided by 3, that's x squared. So I'm saying this and this are the same. Now, this isn't a proof. This is a demonstration, though. And I just wanted to illustrate this. And so what we have, if you'll notice, that power there and that power there are the same, and the index here and the denominator there are the same. So in general, a to the power of m over n, if I have this fraction, is equal to the nth root of a to the m. Now this, in our rational exponent, would be the numerator. I should have considered changing those variables around. And this, the index, would be the denominator when you're looking at the rational exponents. When you're looking at maybe thinking about it in terms of a power instead of writing it in radical form. All right, so that's what I need you to keep in mind. And we're going to work through some of these. Changing radicals into exponential form. Just understanding this concept right here. And then what else we understand about the radicals that we've had before. So if I were going to write, let's say, the cube root of 27. If I wanted to write it in exponential form, I would write it as 27 to the 1/3 power. Either way, it's 3, but I'm just concentrating on writing it from radical form into exponential, because 27 is to the first power, and the index there, 3, is where the denominator goes. All right, well, let's try another one. Let's take the square root of x cubed, y to the fifth, and z. Now, that is going to be, I'm going to split it into three parts. Square root of x cubed times the square root of y to the fifth times the square root of z, which is z to the first. And notice, remember with square roots, you got a little 2 in your index on all those. I hope that was in the shot. Here's what I did. That's what I was talking about. So, this first term, I'll write as x to the 3/2 power. The second part is not a term. The second part of this term is y to the 5/2 power, and then z to the 1/2 power. So that is converted radical form into exponential form. And if I do one more here, let me try this one. Let's put 3x times cube root of x squared. Alright, well that's 3 times x to the 2/3 power. Now if I rewrite, if I say x to the first is x to the 3/3, right? 1 and 3/3 are equal. The reason I'm doing that is I'm going to add this power. When you're multiplying, you add the exponents. 3/3 plus 2/3. So this 3, it has nothing to do with the, it's kind of separate from that. And then 3 plus 2 is 5. 3 times x to the power of 5/3. Okay. All right, next thing I want to do is I want to convert from exponential form to radical form. Let's take one here. Let's take an exponential expression here. X squared minus 7. X squared minus 7 to the negative 1/2 power. I want to convert that to radical form. Alright, the first thing I would be tempted to do is write it in as a positive exponent. Tempted to do that there. Now, radical form. That's 1 over, okay, it's a square root, don't have to write that 2 there, of x squared minus 7 to the first power. Alright, now we could stop there, but we have done a lesson on rationalizing the denominator. The phrase slipped me for a second there. So at this point, I'm going to write it over here. 1 over the square root of x squared minus 7. I'm going to multiply this by x squared minus 7 again. And when I do it to the bottom, notice that x squared minus 7, when I inserted it, I extended my radical. I got to put the x squared minus 7 under the radical because that's where it did in the denominator. So I got 1 over square root of x squared minus 7. And if I rewrite this one, that's the square root of x squared minus 7 times x squared minus 7. I'm going to get rid of that 1. Just multiplying by 1. That's simply the square root of x squared minus 7. I really don't need those parentheses. But this is the square root of x squared minus 7 squared. So the square and the square root, that's how we rationalize the denominator. So I have x squared minus 7 on the bottom. I have the square root of x squared minus 7 on the top. Okay. There's one, converting from here to here. Negative exponent to positive exponent, changing to a radical, and then rationalizing the denominator. Now, next thing, let's do another one of these. Let's take negative 3b to the 1/3 c to the 2/3. Okay. I got the negative 3 out here. Now, the thing I can do here is, if I take b to the first power, c to the second power, and go to the 1/3 power out here, 1 times 1/3, 2 times 1/3, I'll get those powers. Reason is, I'm looking at this common denominator there, and knowing that the 1/3 power is the cube root. Okay, so this is negative 3. Let me write that a little better. Negative 3 times the cube root of bc squared. Okay. Let's try this one. A to the 0.75 power. I think the best thing I can do is change 0.75 to its equivalent fraction. It's just 3/4. And then write it. The denominator is the index, and the numerator is the power of the expression. So the 4th root of a cubed is this. Maybe one more. X squared to the 2/5 power. First thing I'm going to do is power to a power, I multiply. So this is 2 over 1, this is 2 over 5. 2 times 2 is 4. 1 times 5 is 5. X to the 4/5 power is the 5th root of x to the 4th. Okay. Couple more. Now, if we're just given an expression to simplify, let's see what this answer will give us. Negative 125 to the negative 2/3 power. So that is 1 over negative 125 to the 2/3 power. Alrighty. So if I am thinking of this properly, I'm going to go ahead and write this. Cube root negative 125 to the 2/3 power. Not square, sorry. I'm getting rid of that fraction. I'm rewriting it as a radical. And the thing I'd like to do on this is I would like to rewrite negative 125. 5 times 5 times 5 is 125. Negative 5 times negative 5. So that is negative 5 to the 3rd power raised to the 2nd power. So, and what I want to do with that 2nd power this time is, let's erase this bracket right here. We can put that bracket out here, okay, because that cube root and my third power are going to cancel out.
I am eating apple.
So that leaves me with 1. This part is negative 5. This part in the parentheses is negative 5 because the cube root, and the third power are canceling out. Those are inverse operations. And negative 5 times negative 5 is 25. So I'm getting 1/25 there when I simplify that one. Okay. Let's do another one here. I'm getting a little long with this video, but we'll just keep powering through. 4x squared y to the 3/2 times negative 3x to the negative 1/3 y to the negative 3/2 negative 3/5.
Imagine a smaller freight train.
Okay, I'm going to rearrange things here. I'm going to 4 times negative 3. I could just remove all these parentheses and just regroup these factors. X squared times x to the negative 1/3 power times y to the 3/2 times y to the negative 3/5. I'll be right back. Hey guys, recording in here. Okay. I'm too far invested in this thing to start over, so I'm having them be quiet a little bit. Now, negative 4, or 4 times negative 3 is negative 12. I add 2 plus negative 1/3 here for the power of x, and I add 3/2 plus negative 3/5 for the power of y. All right. Let me just get another piece of paper and keep doing that a little bit here. So 2 plus negative 1/3. 2 is what over 3? It'd be 6/3. Plus negative 1/3 is 5/3. So that's my power of x, and my power of y is 3/2 plus negative 3/5, and 5 is a common denominator, so I'm looking at 15/10. Not 5. 10 is the common denominator, plus negative 6/10, and I'm getting 9/10 there. So, as we move along with this, I got negative 12 x to the 5/3 y to the 9/10. I don't think there's any need for us to change that to a radical. I don't think that's going to make it any simpler. So this is my answer there. All right, let's close with one more problem. And that is the third root of the fourth root of 27. All right, interesting problem here. So notice that is the 1/3 power, remember, and this is the 1/4 power. So I take the 1/4 power to the 1/3 power. I essentially will multiply those and get the 1/12 power. So I could change this to the 12th root of 27. Now, with that in mind, we've seen 27 several times here and written it as 3 to the third. So this is 3 to the 3/12, which is 3 to the 1/4, which could be one version of the simplified, or the 4th root of 3 if we wanted it in radical form. Okay, maybe just watch what they're asking you to do as far as what form they want it in. Okay, guys, I know that's long for the videos I give, but it's all done. So take care, and I'll see ya.